So a very good evening to one and all present here. My name is Barnik Goswami. I am a MBA student at Department of Management Studies, IIT Roorkee, and at MRC, my project mainly centered around policy suggestions for URN management. Now, we'll be talking about the background, the objective, the URN management measures, the suggestions for policymakers, and lastly about capacity and capability building. Now, starting with the introduction, URN chiefly refers to noise from three parts of a ship, namely the hull, propeller, and the machinery. Now, over the past few decades, URN levels have risen rapidly due to mostly anthropogenic causes, such as the tremendous increase in shipping and the percentage of global seaborne trade. A relationship exists between the change in underwater noise levels and shipping, which is shown here. And though URN is a growing cause of social and environmental concern, uh, not much steps has been taken to curb it, as in sharp contrast to other marine pollutants. URN is generally intangible. Now, coming to the impacts of URN, URN has impacts on both marine animals as well as socio-economic impact on humans. Now, for marine animals, it starts with acoustic degradation, which is where URN interferes with the perception of habitat of marine fishes and animals. Then URN can also lead to acoustic masking, which is the tampering of the long-range communication signals that marine mammals often use to communicate. And as these marine mammals often use sound to communicate and perceive their environment, high levels of ambient noise can also increase their environmental stress and consequently lead to changes in their behavior, growth rate, and reproduction as it interferes with hunting and interspecies communication. Next, we come to the socio-economic impact on humans, and the first would be the impact on fishing, as URN affects the breeding rate and the growth of fishes. It impacts marine tourism. URN is also shown to disrupt sustainable development and can even lead to loss of livelihood. Now, coming to the gaps and limitations, I would be specifying them in the Indian context specifically. Now, though many studies have shown the negative impact of URN on marine ecosystems, there is still a lack of substantial knowledge uh, quantifying the extent of damage that URN causes. Another hindrance to policy formation has been the uncertainties surrounding the effectiveness and efficiency pollutants. Noise has to be quantified at the source and with respect to the surroundings. Like a ship emitting the same level of noise would be much more threatening when passing through a rich biodiversity zone than when passing through an largely uninhabited expanse of the ocean. Also, capacity and capability building is a challenge in a country like India, where a large section of the workforce lacks formal technical education. Now I come to the objectives of my project. With the objectives have been to identify the stakeholders and the policymakers for URN management in the Indian scenario and how can they come together for policy formation as well as enforcement. Also, I have analyzed existing policies and laws in place by the stakeholders and like how measures to curb other forms of pollution translate to URN management. And then lastly, it's about adapting the state of the art global policies followed by the American subcontinent as well as the European Union with respect to managing of URN and figuring out ways to implement it for India. Some of these would be like utilizing monetary incentives, certifications for noise emission in limit, tax subsidies, etc. Now I come to the technological measures for URN management. Now, as mentioned previously, the sources of noise from commercial ships and vessels can be classified into propeller, machinery, and hull. And the primary way of reducing hull noise would be to come up with an effective design. And it has been shown by multiple research papers that with a meager 1% increase in the manufacturing cost of a vessel, a noise reduction of as much as 10 decibel is possible, which increases to 20 to 40 decibels of noise reduction with just an additional 10 to 15% building cost. Now, another significant source of noise from vessels, which accounts to almost 80 to 85% of the ship's total noise, would be propeller cavitation. So above the cavitation inception speed, the rotating propeller generates oscillations, and it causes variations in water pressure large enough to cause bubbles of water vapor to form, which subsequently collapse and emit a substantial amount of noise. Now, cavitation can again be reduced by modifying the propeller and by exploring new technologies such as the contracted load tip propeller, high skew propeller, propeller boss cap fin, etc. Moving on to operational measures, ship speed restriction is currently the most effective operational measure shown to reduce URN levels. However, it comes with a trade-off that the slower vessels take a very longer time to transit, leading to a trade-off between the duration to which the noise is duration in which the noise is emitted, as well, and the intensity of noise exposure. So one study indicated that an optimal trade-off might be obtained between this duration and intensity at a speed of roughly around 8 knots. Also, poor maintenance can lead to marine fouling on the propeller, and this can henceforth increase cavitation as well. And this would also increase the surface roughness on the hull, which would increase drag, thus even leading to consumption of more fuel. And also, regular maintenance of the propeller and hull may therefore achieve reduction in URN as well as lead to less fuel consumption. Now, coming to activity reduction measures. Now, many of the European Union countries have adopted policies incentivizing the use of fewer larger vessels for shipping cargo. Like, it has been shown that although large vessels tend to generate more noise, their greater carrying capacity often offsets their higher noise output and thus reduces the cumulative noise levels. Also, spatiotemporal restrictions can be put on shipping routes, specifically to avoid sensitive areas of the ocean during particular periods of the year, such as during the breeding season, or maybe avoiding the whale or marine mammal migratory routes, etc. Now, I have come up with a schematic diagram for URN management. On the leftmost side, the red boxes briefly relate to the URN emission right from the causes of URN leading up to cumulative URN levels. The next column shows the subsequent, the next two columns rather, show the subsequent measures that could be undertaken to reduce noise at that particular level. For example, suppose we start with causes of URN generation in the leftmost column, and this can be reduced by policy controls and subsequently technological and operational measures. And the rightmost column shows the examples. For example, in case of technological and operational measures, it could be quiet ship design guidelines and promotion of research to improve vessel design to reduce URN. Next, I have classified measures into measures for new vessels as well as measures for existing vessels. Now, in case of new vessels, substantial research must be undertaken to form a quiet ship design guideline, and this should be enforced at the design stage, either via economic incentives or with mandated standards. Now, enforcing mandatory standards based on the noise output of individual vessels does seem to be the most easy option here. And a different approach could also be taken where the noise requirements are scaled to vessel transport capacity, and targets are undertaken to reduce the noise to capacity ratio of a vessel. Next, we come to measures for existing vessels. Now, an international standard does exist for measuring ship noise emissions, but it does not take into consideration the operating conditions of the vessel. But noise output from a vessel will vary with ship speed and even with other operational or environmental factors. And hence, measurements should be made under realistic conditions. When we translate that to the case of India, measurements should be taken along shipping routes rather than around ports. And these could be easily implemented in high density shipping routes in the Bay of Bengal as well as the Indian Ocean. Now, registries of vessel noise output could then be compiled at a national level, and that could be updated periodically so that the stakeholders do have a database of the noise emissions of ships. Now, this program can then subsequently offer some incentive to ship owners to have their vessels assessed periodically, and if their noise emission levels are in a particular limit. This would also ensure that vessel operators have some incentive to undertake periodic maintenance. Next, I come to the capacity and capability building. Uh, for this, a central data pool of information can be developed, which would be a way for stakeholders to share know-how as well as their progress on the efforts they are undertaking to curb URN. Now, one of these primary efforts could be to undertake the formation of a state-of-the-art ship design guideline, which would again be shared with the shipbuilders, owners, operators, the shipyards, etc., through the aforesaid data pool of information. Then another step would be to undertake the education and training of operators, associated personnel, and everyone else involved with ship operation as well as in yards, both onshore as well as offshore. Also, substantial research must be undertaken to quantify the effects of URN and appeal to stakeholders the financial benefits of quieting the oceans. That would be all from my side. Thank you.